Hello everyone, I am Harichandana. Today I am going to tell about the nonlinear support vector machines. The nonlinear support vector machines are used to project the data that is not linearly separable into a higher dimensional space. A nonlinear transformation is needed to map the data from its original feature space into new space where the decision boundary becomes linear. After doing the transformation, different methodologies are used to find the linear decision boundary in the transformer space. In the transformer space, parameters can also be found. One potential problem with this approach is that it may suffer from the curse of dimensionality problem often associated with high dimensional data. Nonlinear support vector machines can avoid this problem by using kernel trick. So my question is how to avoid the curse of dimensionality problem often associated with high dimensional data. So the answer to this question is nonlinear support vector machines can avoid this problem by using the kernel trick. Thank you.
Learning a nonlinear SVM model. Here, the nonlinear SVM model is different from the linear SVM model. It uses phi x instead of x to represent the transformed high-dimensional features. Now let's assume we already know the phi x. So the formal expression of the nonlinear SVM learning problem is like below this formula. And it is similar to the Lagrangian in linear SVM. The left is the linear version and the right is the nonlinear version. We can easily notice the differences is the left one has xi dot xj, but the right has phi xi dot phi xj. And similarly, the nonlinear version w and b are like below. So basically, the nonlinear SVM model, the learning part is similar to the linear part.
Hello everyone, this is Satabdi Reddy and I am here to discuss about the issues in nonlinear support vector machines and its solution. As one of my friends has previously discussed about the nonlinear support vector machines, we know that it may suffer from the curse of dimensionality problem with high dimensional data. So one solution is to transform the data into infinite dimension space, but at high dimensions it is not easy to work with. Even if the appropriate matching function is found, solving the problem at a high dimensions is a computationally expensive task. After the transformation, the decision boundary is similar to that of a linear decision boundary. To solve this problem, we use kernel trick. The kernel trick is a method for computing similarity in transform space using the original attribute set. The dot product between two vectors in transform space can be expressed in terms of similarity function in the original space. The similarity function is known as the kernel function. The kernel function used in nonlinear support vector machines needs to satisfy a mathematical theorem called Mercer's theorem, which states that kernel function can be expressed as dot product of two vectors if there exists a function g of x such that integral g of x square is finite. Then integral of the kernel function into g of x, g of y should be greater than or equals to 0. Examples of some positive different kernel are listed below. So my question is, why do we use kernel trick? Kernel trick is used to solve the high dimensionality problem associated with nonlinear support vector machines. Thank you.
Hello everyone, I'm Abdullah Rokibul Islam. I will give an example of applying SVM to datasets that have nonlinear decision boundaries. I will show how we can apply a trick to transform the data from its original coordinate space into a new space so that a linear decision boundary can be used to separate the instances in the transformed space. After doing the transformation, we can simply apply the method that is presented by Arcash to find a linear decision boundary. I will only show how we can transform the data. The figure here is showing an example of two-dimensional dataset consisting of squares and circle. You can see the dataset in figure A. From the dataset, we can see that all the circles are clustered near the center of the diagram and all the squares are distributed further away from the center. Our goal is to transform this data into a way so that we can draw a linear decision boundary uh, here. So instances of the dataset can be classified using this equation 1, and the decision boundary of the data can therefore be written as the second equation, which can be further simplified into a quadratic equation showing in the third equation. Okay, so we know that we need a nonlinear transformation phi uh, that will map the data from its original feature space into a new space where the decision boundary become linear. Suppose we choose this phi as like this, from x1 it will be transformed to x square, and the x2 that will be transformed into x2 square. So and thus we found the parameters w like the last equation. Okay, so for illustration purpose, let us plot the graph of x2 square minus x2 versus x1 square minus x1 that is showing in figure B. So in figure B, we can see that the transformed space, all the circles are located in the lower left hand side of the diagram, and now the problem is transformed into a linear SVM problem. And here we can apply a linear decision boundary that can easily separate the instances of the respective classes. I like to take a question from you. Okay, so the question is what is the potential problem with this approach? Thank you for your question. One potential problem with the approach is it may suffer from the curse of dimensionality problem, often associated with high dimensional dataset. Shatabdi already demonstrated how we can avoid this problem using kernel trick. Thank you.
Hi, my name is Sarang Padarkar, and today we will discuss the advantages and disadvantages of support vector machine. So, so the advantages are the support vector machine is works very relatively well when there is clear margin of separation between classes. Support vector machine is effective in high dimensional spaces. Support vector machine is effective in cases where number of dimensions is greater than the number of samples. Support vector machine is relatively memory efficient. Let's discuss the disadvantages now. Support vector machine algorithm is not suitable for large datasets. Support vector machine does not perform well when the dataset has more noise, that is, the target classes are overlapping. In the case where the number of features of each data point exceeds the number of training data samples, the support vector machine would underperform. So let's come to the question part. Uh, can you list down one advantage and one disadvantage of support vector machine? So here's the answer. So the one advantage is that support vector machine is memory efficient, and one disadvantage is that support vector machine does not work well with large data sets. Thank you.
Hello everyone. I'm here to present the characteristics and application of SVM. So let's head on to the presentation. So here I have the characteristics of SVM. First, as you know, that SVM provides efficient algorithms to tackle the learning problem to find the global minima of the objective function, whereas the other methods use the greedy approaches and find the locally optimal solution. Next, it addresses the overfitting issue by using a concept of maximizing the margin of the decision boundary, but still the kernel function and the cost function needs to be provided for this purpose. It gets difficult to handle the missing values when using SVM. That is one of the advantages and disadvantages of it. Next, it is robust to noise. It reduces any kind of noises present in the process. It has high computational complexity for building the model. It's one of the main characteristics of SVM. Moving on to the applications of SVM that we have, which are used in the real world. It is helpful in text and hypertext categorization, and it reduces significantly the need of inductive and transductive settings. It helps in the classification of images. Experiments have shown that SVMs have significantly increased the search accuracy as compared to the traditional query refinement schemes. It also helps using SVM can also be used to do the classification of satellite data like SAR data. SVMs have a recognized handwritten characters. That is one of the main applications of SVM. Also, the last and not the least of the applications, the SVM algorithm has been widely applied in biological and other sciences. They have been used to classify proteins with up to 90% of the compounds classified correctly. My question is, state one application of the SVM which enables the experiments to achieve significantly higher search accuracy as compared to the traditional query refinement schemes. The answer is, by the classification of images, the SVMs help us to do so. Thank you.